Hey guys, hi. What is up? How are you all? I hope so everyone is all right, fine. So I welcome all of you to yet another new stream. So in this stream, it's an exciting Menti quiz session. So my first request would be hit like the session, subscribe the channel, and just think of today's target, right? So today's target, I'm putting it to be, you know, 15 likes until the end of the session. Okay. So I hope so you would be able to uh, get me to that aim. Okay, so now as you can see, I would just tell you one thing, that is, I welcome all of you to the stream. Okay, all those who are watching me live, as well as those of you who are watching this as a replay. Okay, so let me first show you how do you join. Okay, the quiz. Okay, let me show you how do you join the quiz. Yes, you can see here, you have to just type over here www.menti.com. Okay, as you type this, a code would appear you over here. Okay, so that you need to do one thing. So you have to type today's code, which is 100 241 241 24105. There's your code and just submit it. Okay, as you submit it, this type of a screen would appear to you. Okay, like this you're gonna just join the quiz. Okay, that is the way you're gonna join the quiz. Okay, next. Okay, next thing would be, how do you join this screen? Okay, so this is our small channel. As you can see, there's, I put the banner today itself. Okay, there's your content for everything, and what you would do is just here's our screen, what it is looking like. And over here we have this playlist ready for all of you, made with geography, history, motivational hacks, chemistry, biology, physics, mini quiz, and all the other sessions. So that is it. Okay, that was the thing which I wanted to show all of you. Okay, so now let's head forward towards our main session, which is Menti. So let me present the screen before you all. Okay, so this is our screen. You would see it. Okay, so just go to www.menti.com and just put on this code 10024105. Okay guys, I'm doing one thing. Okay, wait just a second. I'm doing one thing. I'm just putting up my video. Okay, you all just see the whole screen, and yeah, my audio would be there to you. Okay, so let's, you all do one thing. One screen you would open for the quiz. Okay, and another one for the watching the stream. Okay, I can see three of you joined. Thank you very much. Now over here, there's streaming on YouTube. This is our channel logo, and there's your live stream. And subscribe to the channel if you like this type of content. Okay. So now the thing is very simple, that you just, let's go forward now. So this is the screen. Okay, over here, this is the code for the quiz. Okay, this is the code. Okay, let's go forward. Let's see how many of you do. But guys, I would like to just tell you one thing, that before beginning any session, it is very important, I personally think, it to begin with the this quote. Okay, so today's quote is Tesla quotes that electric that will electrifies your life. Okay, That is a big motive. Okay, so keeping that in mind, let's go forward. Today's topic is, by the way, electricity. Okay, so how many of you are, three or two of you are watching? I would like all of you to join the screen. Okay, come on, let's join the quiz first. Let's see how many of you have joined. Two have joined. More participants. Let's wait for a little while until you all join the screen. Okay, let's go. Let's go. Let's go. Let's go. Come on. I'll wait for next 2 more minutes, and then I would start up with the uh, showdown. Okay, my screen would be visible to you now. Okay, so let the page get refreshed a little bit. Okay, okay, there you see. Let's go forward. Let's see how many of you but right in this screen. Okay, guys. Guys, two of you have joined. Come on, join first. Welcome to the stream, all of you. I would just like to tell all of you that hit like the session and join the quiz very fast. Two of you are watching, join the quiz. Call up your friends. Hi, Shivartik. Yeah. Okay. So today's, this motive of bringing this thing is keeping in mind of helping you all. Okay. Uh, so I would not waste much of my time, guys. Just do fast, and just call up the friends. Okay, three of you are watching. Hi guys, hi. Come on, guys. Just comment me in the comment box. Uh, three of you watching. Yeah, thank you for watching this stream. All of you comment me in the comment live chat. Okay, please join the quiz fast. Okay, cause I'll be waiting for another 30 more seconds and we will be starting off. Guys, come on. Call up your friends, ask them to join for the quiz. Come on. Yes, today's like aim is up to 15 likes. I believe you all will help me achieve it. So I'm doing one thing without any further delay. I'm starting this session. Okay. So meanwhile, you all just join. So hi guys, three of you watching me, right? So the third participant, may you please join the screen within 10 more seconds. I'll be starting off with the quiz. Okay. Okay. Come on. Okay. Let's go. Okay. Come on. Yes. So count down with me. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There you go. Your first question at your screens. Answer fast to get more points, obviously. 1 joule equals to what? Is it 3.6 into 10 power 6 kilowatt per hour? Is it 1 watt per second? Is it 746 watt per second? Or is it 1 kilowatt per hour? Which one do you think is the correct answer? Answer fast. 3, 2, 1. Time's up. Time's up. Wrong answer. Both of you are wrong, buddy. It's not 3.6 into 10 power 6. It's 1 watt per second. We knew power is equal to work done upon time. So work done is equal to power into time. Power's unit is watt. And this that will be work done is equal to power into time. Okay, so that is the correct answer. Let's go forward towards the second question. All of you, please, requesting all of you, please, all of you, just call up your friends, because otherwise we can't get more players. Only two of you are playing. It will not be a good competition. Okay. So for making it a good competition, I am requesting all of you, please, please, all of you, just call up your friends and call up your neighbors also who are studying from 10th standard to join in this session. Okay. Okay. Come on. Come on. Let's go. Answer fast to get more points. The maximum resistance that can be obtained from three resistors, each of 6 ohm, is, what do you think is the correct answer? Three resistances, each of 6 ohm. Maximum resistance, you remember? When we put all of them in series, answer is 18 ohm. God, it's not 3 ohm, it's 18 ohm. Don't make this mistake, because we are putting all of them in series. Then only we'll get maximum resistance, no? Let's go. Third question up on your screens. Okay, let's go. The maximum resistance that can be obtained from three resistors, each of 6 ohm. Oh God, this is simple repetition. I think this is simple repetition. Hit the right answer. Hit the right answer. Nah, it's 2 ohm. Minimum resistance. So 3 each of 6. So 1 upon 6 plus 1 upon 6 plus 1 upon 6. Ultimately, it's going to come 1 upon 2, which is the minimum. So on reciprocating it, you would get the answer as 2 ohms. Let's go towards watching our fourth question. Guys, I would just request all of you, please. Yes, Rovam. Hi, Rovam. Yeah, bad joke that was. Okay, okay. Come on. Let's answer. Let's go forward. The three resistors of 1 ohm, 2 ohm, and 3 ohm are connected in parallel. Combined resistance of the three resistors should be what? 2 ohm and 3 ohm are connected in parallel. Combined resistance of the three resistors should be what? One is correct, which is less than 1 ohm. Okay, let's go forward towards watching our first leaderboard. No, it's the fifth question. It is the fifth question up on your screens. Hi guys, all of you, three of you watching. Thank you for watching. Join up the quiz fast. We are up to the fifth question at our screens. Let's go. Let us go. Rock it up. Answer first to get more points. An electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power drawn? Guys, this P is equal to IV. Current is given to you. Just multiply both of these. Multiply this and you would get the answer in watts. Come on, come on, come on, do fast. No, it's 110. It's not 440. Okay. Multiplication. You're making it mistake in multiplying. Okay. Don't do so. Sixth question on your screens. Okay. Are you ready? Are you ready? Are you ready? Are you ready? 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 Let's go. 100 joule of heat energy is produced each second in a 4 ohm resistor. The potential difference across the resistor will be what? Our work done is given and resistance is given. It's 20 ohm. Why are you making this mistake? You shouldn't make this sort of a mistake. Now see what over here you had to do. It's told each second. Okay, this is each second in a 4 ohm resistor. So what do you knew? It's work done is equal to H is equal to I square RT. So I uh, or VIT you had. Work done is equal to VIT, right? The V I was given to wait. Yeah, work done is equal to V square T upon R. It was the formula. Okay, you have to put 100 joule is equal to V square, which is V square. You have to keep it into T, which is 1 second, upon R, which is 4 ohm, and then you would get the answer as 20 volt. Do fast. It is going to be hard, really hard. Okay, let's go. Let's make it up for the 7th question, which is at your screens. Yes, if the potential difference across the ends of the conductor is doubled, then the current flowing them the half time. What do you think is the correct answer? Yep, you're right. Absolutely, you're right. Very nice. Come on, let's see. Oh my god. Physicist Pragyan, he is just leading, no? Wow, nice. Very nice, Pragyan. Followed by Shivartik, who had given only one correct answer. So, three of you are watching. Thank you for watching. Rohan, where are you? I can't see you. Come on, buddy, participate. What happened? Only two of you are there. Let's go. Eighth question on your screens. Guys, do one thing. One screen you would open for laptop or mobile for watching the stream, as well as one screen you would open for making answering the questions in the quiz. Okay, come on. Here's your question. A fuse wire is inserted in a what? Is it live wire? Is it neutral wire? Is it earth wire, or may not be connected in any of the lines? Come on, answer this. This is very tricky, huh? Very tricky answer this is. Okay, yeah, it's so simple. Correct answer. What to do here? It's so simple. Damn. Damn. It's damn simple, right? I know. I know. Hey, you are not teaching me, huh? I know. So there's your ninth question at your screens. Come on, let's go. Okay, answer first to get more points. The purpose of a rheostat is what do you think is the right answer? Is increase the magnitude of current, decrease the magnitude of current, increase or decrease the magnitude of current, or is it none of the above? Come on, answer first. Answer first. Yeah, one of you got the right answer. Hi guys. Oh, thank you. Five of you are watching. Thank you for watching. Please answer in the live chat so that I can understand that you all are there. Okay, and please join the quiz fast. You're gonna have a bonus which is left at the ending. Okay, you're gonna have a super bonus at the end. Okay, I'll tell you why. Okay, so let's move forward. Yes, so there's your 10th question at your screens. Hi Rovam, please attend the quiz. What happened? You all are not participating, only two of them. I told you, no, one surprise is there for all of you. Just wait for it. Let's go forward. Where does, okay, resistance of a conductor is directly proportional to what? Ohm's law. Come on, answer first. It's cross sectional area, density, melting point, length. Which one do you think is the correct answer? Resistance. Mind it, resistance. Absolutely correct. Very nice. R is equal to rho L upon the correct answer. Very nice. You all are rocking it. You all are simply rocking it. Okay. So there's your 11th question at your screen. Okay. Come on. There you go. There you go. Okay. A 16 ohm resistor is bent on itself. The resistance of the new wire. Remember the formula R is equal to rho L upon A. Put the same formula in answering this question. Is bent on itself. So area is made twice, length would be made half. It will be 1/4, which is, oh no, it's 1/4. See. The logic is 16 ohm is given to you. It's told it is bent on itself. So what happens? One rod is there. That rod is bending on itself. So ultimately area is gonna be twice. Okay. And over then, so what happens? Volume remains constant. So if the length gets to area gets twice, then the length would be obviously halved. So ultimately we knew that R is equal to rho L upon A. So from there you can tell that rho L upon A. Okay, area it has become twice, so length will become half. Ultimately that half gonna come down and become 1/4 of the original. So 1/4 of the 16, what it becomes? It becomes 4 ohm, right? That is the correct answer, not this. Both of you got it right. Wrong, sorry. Let's move ahead. Okay. Your final judgment question at your screens. So get ready. Okay, let's go. Last question at your screens. Calculate the resistance of the question. Very easy question. Mind it, very easy. Calculate fast. 6 and 6 in series, 12. 12 with 6 in parallel. Come on, fast. It is 4 ohm. Rovam, it's not invalid, buddy. Moreover, you all are too late. Okay, it's all over. It's all over now. And undoubtedly, our winner for this quiz is no one but our special buddy, friend, collab, very nice, good friend, Pragyan. Very nice, all of you. Very nice. Not only Pragyan, but I would also like to congratulate each and everybody of you who had been there. Okay. Now, as I was telling you, know, what's the damn surprise all over this? Okay, so buddy, today's surprise is something very nice. Okay, so I'll tell you why. I'll tell you why. Because see, today we're gonna discuss the chapter wise analysis of questions from the chapters of physics. Okay, so wait for 1 minute. I'll be coming back and telling you what are the important points do you need to study from our book. Okay, just wait a minute. So guys, everyone, please bring your physics book. Okay, bring the physics book from wherever the place you keep at your study table. Okay, bring it fast. Even I have myself arranged for this book, and even if any one of you having any doubt, please write in the live chat. Okay, I am reading through the live chat and I'll be answering to each and every doubt of you. So I would be sharing with you my personal experience of how do you know get about these small topics and understandings which you should do at the final moment. See, we have got only 2 more months for the boards. Okay. So practically speaking, you need to go strategically. Okay. And that's why through these Menti sessions, I'm gonna tell you how do you get about things fine. Okay. So enough of those philosophy. Now let's come back to the point. All of you answer me in the chats. How many of you have brought back your books for the study which you're gonna do now? Okay, I hope so everyone can hear me now properly. Okay, so all of you just pick out your book and come to your examples. Okay, I'll be not going in depth. I'll be just telling you the important questions that you need to do from your book and practice for your exams. As per my perspective, it is okay. Okay, from here you see the all of you just answer me in the chats. How many of you are you know uh, have got your books and you are ready? Just tell me one. Just tell me. How many of you are ready? The stream is gonna go fluently till next more half an hour. So call up your friends. Okay. No more of quiz. Quiz we did. How many of you are late? That's so sad. So now we're gonna discuss only about the text. Okay. Come on. Answer me in the chats. How many of you are watching and how many of you have brought your books and started marking it? Okay, come on guys, our target today is 15 likes. Okay, so let's reach up to 15 likes at least at the end of the session. Okay, hi everyone. Hi. So wait, now let's get a little serious. So the first thing from this book are, see, this ICC Selina concise physics. I hope you can see it now. Okay. This book, this is our textbook for physics. Okay. So strategically speaking, what you need to do now is that take out your examples on page number 7. Do first take out that page. Okay. Picked out? I hope so. Answer me in the chats. Okay. In the live chat, write something so that I can understand that at least somebody is there to hear my voice. Okay, or else it's being like speaking to you know host. So let's go forward now. So in your examples on page number 7, first you mark the question is question number from question number 1, 2, 3, 4, 5, 6. All these 6 questions over here are very important because they are based on your conceptuals. Testing all of the concepts from these things, which is moment of a force, equilibrium, translational motion, rotational motion, linear motion, moment or turning effect of force, then your measurement, which is the torque, then your examples, then your couple, moment of couple, equilibrium. From all of these things, all these are mixed matched. Okay, so understand that very nicely. Okay, next you turn over the page to page number 8, and on page number 8 you mark the question number 9 as very important. You mark question number 9. See, I'm not going through in depth for all the questions. I would be telling you only the questions that are most important. Okay, mark the question number 9 and practice it well for your exam. Okay, next question is question number 11. Question number 11 is very important, huh? So keep in mind that question number 11 also you practice. Okay, next you practice which is come to the exercise. In the exercise portion you mark the questions. Exercise portion, have you all come? Please write in the chats. Please let me see how many of you are watching. Okay, so over here I can see question number 6, 7, 8, 9, 15, 16, 19 and question number 25. These are the questions you need to mark and practice it well enough. Okay, once again I'm repeating it, please cross check, which is question number 6, 7, 8, 9, then your question number 10, 15, 16, 19 and question number 25. These are very important for understanding the depth of the exercise. Okay, now I'm gonna go exercise by exercise. Okay, next question is MCQ types. These are common types questions you need to get in your head because these are very conceptual based. Now numericals are very important. Physics, see, physics is absolutely incomplete without the numericals. Okay, so if you want to get full marks in physics, you need to work hard on the numericals. Understanding the concepts is as much as necessary as solving the numericals. So in the numericals portion on page number 11, mark the questions 3, 4, question number 5, 8, 9 and once again let me repeat from this page itself, which is question number 4, 5, 6, 8, 9, 11 and on page number 12 mark the questions which is 14th and 17th, 18th also. So 14th, 17th, 18th from page number 12. This is very important. Okay, so next portion, which is the B part, which is you know to understand, that is center of gravity. Center of gravity concept you need to get straight and understand it in depth. Okay, after that you need to understand this chart in page number 13, which is the center of gravity of some uniform bodies. So that should be, you know, that should always flicker in your mind, because each and every question, because few of the parts they're little bit turning and twisted, because you see question can come that where is the center of gravity of a hollow cone and a solid cone. You might make mistakes, no? This part is very confusing. Okay, so making confusions in your mind, you should avoid that. Learn this chart very nicely. Next is exercise 1b. Over here mark the question 3, 5, 7. Once again I'm repeating question number 3, 5, 7 and over in page number 15 mark the questions 10, 11 and MCQs are very necessary, particularly the second question in the MCQ. Okay, so understand that question in depth. Okay, next question comes from uniform circular motion. In uniform circular motion, you need to study what is actually uniform circular motion. Next is direction of velocity at any instance. Over here, you need to study the what is centripetal force, what is centrifugal force, and their examples are very necessary. Yes, hello Rohan. Yes, tell me. Ask me in the chats. Hello. Yes, Rohan, tell. Okay. Meanwhile, you type. Let me, go forward, which is in the. Okay, okay, no problem. Okay, Rohan. Okay. Over here in exercise 1C, you mark the question which is uh, okay, okay, Rohan. Okay, you mark it. Okay, mark the things which I'm telling you. Mark the things, and even you can just replay the session and watch it from beginning. This was the trick, or you can say the my thinking behind asking you to join for the Menti quiz. Because other sessions, my previous sessions of Menti, was to bring only for the quiz, but this one is a bit different. That is why I marked it beforehand and asked you to all of you, come on, then you know, uh, join this session. Okay. So over here in exercise 1C, you need to answer the questions. Question number 2, question number 5, question number 11th, question number 12, question number 13, question number 14, and MCQs both. So keep that in mind. Guys, all of you just knock this video to all of those who are, our classmates, our class 10 classmates. Okay, please ask them to join for the quiz. I mean, for this session. It's so weird at times. So, what do you want? Now tell me, what do you want? You want the detail wise explanation of each of the chapters in physics. Is it so? Because I actually love physics a lot because physics has been always my favorite subject. So I can practically go about with the in and outs of physics at least for all of you. What do you want? Tell me in the chats. Should I revise you? Which chapter should I revise you? Tell me once. Which chapter? You tell me which chapter do you want to revise? Yes, Roham, which chapter? There are so many chapters, no? You remember my first the conceptual video that I brought was from the foods, and today I'm doing the revision of that foods chapter I did. Revision of chapters, I mean to say which chapter you say? Okay, radioactivity you want to do. Only one, three of you. Yes, I'm doing with the radioactivity. Let's get the assist from the others. Yes, others. Please write in the chats. Other than Rovam is being a very diligent. He is always been supporting to me in growing my channel along with Gaurav. So I'm really very glad to have such near and dear friends. So no more any of such personal discussions. Let's get back to the topic. Okay. On your request, I am bringing this 283. Take out page number 283. We're gonna destroy this chapter. Yes. So before beginning this session, this chapter, I would like all of you just keep one concept in mind. Radioactivity is such a phenomena which is not a, what to say, chemical phenomena. It's nothing related to the chemicals and chemistry. Okay? It originates its few of the concepts of mass number, then your atomic number from chemistry, but it is not a chemical. It has got nothing to deal with the chemical part because it's a nuclear phenomenon. Okay. Now you need to understand what is the structure of atom and nucleus. First, we know that electrons were discovered by J.J. Thomson. Then are alpha particles, that scattering experiment by Sir Rutherford. And then towards the end of 19th century, many other things were further discussed and discovered. So what is the structure of an atom? You need to understand that first. See, an atom consists of electrons, which is revolving around the center nucleus, and in the nucleus we have got a proton and one neutron. Neutron is the neutral particle, proton is the positively charged particle, and as well as the electron which revolves, that is the negatively charged particles. So altogether an atom is electrically neutral. Okay, so that you need to keep in mind. And there was a very popular formula to understand this is by the 2n square, which is the number of electrons. Yes. So that you need to keep in mind. And KLMNOPQ, like this you name the shells. Next portion comes is structure of nucleus. Nucleus is actually at the center of an atom and its size is very small. You can see 10 to the power minus 15 is also known as Fermi. Fermi, that is the unit. Okay, you should remember that. Next, what do you mean by atomic number? What is this atom? Atomic number is nothing but the special number for each of the atom for which it is specialized. It is the total number of neutrons. It's the total number of electrons or protons in a neutral atom. And how do you denote this atomic number? Obviously by the sign Z. That is the symbol to denote it. Now, the mass of an electron is negligible. Obviously, because it's 9.1 into 10 to the power minus 31. Whereas, if we consider the mass of a proton or a neutron, it is 1.67 into 10 power minus 27. So that concept is very necessary for understanding this in depth. Okay. Next, it is given that neutron always it has no charge, electron is negative charge, and proton is positively charged. What do you understand by mass number? What do you understand by mass number? So simple. So mass number means nothing, my friend. It means that it is the sum of the nucleons, which is the sum of the number of protons and the number of the neutrons in a a neutral atom. Okay. Next point is atomic model. Few of the models are given in our book, which is number of electrons, which is Z, then a number of protons, which is also denoted by Z because, as I said, they are equal. Next point is number of neutrons, which is A minus Z, because we knew what our mass number is number of protons. Okay, so understanding that thing in depth is very necessary, because this number of neutrons, we knew that mass number is number of neutrons plus the number of protons. So ultimately, if we deduct the mass number, the atomic number from the mass number, would get this as the neutrons. Oh, thank you for your compliment. Extremely thank you. It is my glad. I feel glad to help you out with this concept. So these models are very necessary. These are very elementary in understanding. Okay. So next page. Let's come over here. See, keep in mind these notes which are given, no, marked as notes with blue color boxes. Understand and read them thoroughly before your exams. That is very necessary. Next, it's given to us, if an atom undergoes a chemical change occurring at low energy, change in the orbital electrons of an atom, where if the atoms undergo nuclear change, obviously nuclear phenomena is not a small thing. It is the very big dissociation, and it gives out a lot and lot amount of energy. And in case of chemical change, it is a very small amount of energy is liberated. In case of nuclear change, it requires higher energy. I told you it is of mega electron volt, which is 1.6 into 10 to the power 13 joules, as far as I remember. Next, which is 10 to the power 6 times the energy required for few EVs only. That is for electron volt. Now, in a nuclear reaction, basically, what happens is that the atomic number, that is the total number of protons, and the mass number, which is the protons and the neutrons, remain conserved. That is the key concept in understanding the radioactive emissions. Okay, so keep that concept in your mind. Next is isotopes. What are isotopes? Isotopes are nothing but the atoms of the same element having the same number of protons, which is the atomic number, but different mass number because of the difference in number of neutrons. Neutrons make the difference over in the isotopes. So you need to understand that well. Now, atoms of isotopes have the same number of protons but different number of neutrons. Yes, as I said, you remember hydrogen has three isotopes: protium, deuterium, and tritium. So over there, the atoms of isotopes have the same number of protons but different in the number of neutrons. Okay, so over in hydrogen, protium has got practically zero neutron particle. Over there, deuterium has got one and tritium has got two. So like that, it makes the difference. Okay, see the chart is given. Similarly, hydrogen has three isotopes, protium has one, tritium has two. Yeah, so we are going through the examples. Okay, for carbon, it is three isotopes, which is C12, C13, C14. C14 is a very radioactive, remember. Chlorine, in nature, there are two atoms of chlorine. One is chlorine 35 and the other one is chlorine 37. Over there, the difference in the number of neutrons make it all different. Yes. Tin, remember this. It's once again made in the box. Tin has the largest number, which is the 10 number of isotopes. Similarly, isotopes are of two kinds. One is stable isotope, one is unstable isotope. Stable isotope, they have got the almost nearly the same number of protons and neutrons. But in case of unstable, remember this. Remember the ratio which I'm telling you. Pay high attention to know what I'm going to say. Isotopes which have the proton by neutron. Okay, let me tell you once. Wait. So when the atomic number exceeds 82 and the number of neutrons is greater than the protons, such that the n by p ratio, which is number of neutrons by number of protons ratio, is greater than 1.5, that means it becomes very radioactive. Over here you see, in C14 you see, it is 14 is the mass number and 6 is the atomic number. So from the number of neutrons is 14 minus 6, which is 8. Okay, n by p, n is 8 by p is 6. So 8 upon 6, what is the calculation? More than 1.5. Ultimately that is more or nearly 1.5. So that becomes very radioactive. Understood? Very nice. In uranium 235 and 238, each of the isotope have 92 and 95. These we will just undergo while we are studying the emissions. Next part is, what are the isobars? Not the chocobars. Okay, these are isobars. Over here, you see the atoms of different elements which have the same mass number, which is A, but different atomic number. They are called as isobars. So the atoms of isobars have got the same number of nucleus in the nucleons in the nucleus, but different number of protons. What happens in case of isobar? They have got the same mass number, but different atomic number. Remember the case of carbon and nitrogen? Carbon also has the 14 mass number and nitrogen also has the 14 mass number, but in case of carbon it has got 6 atomic number and for nitrogen it is 7. Okay, now if the number of protons and neutrons get interchanged in the nucleus, they are called mirror isobars. In case of sodium and magnesium, you see it is 2311, it's 2312. For case of sodium, it has got the proton which is 11, and the case of neutrons, it is 12. In case of magnesium, the atomic number is 12 and the the number of neutrons, it is 11. So they are interchangeable. That is why they are known as mirror isobars. Isotones have got the uh, you know different number of protons but the same number of neutrons, because they have got the different z, which is the the number of protons but the same number of neutrons. Number that the z would differ, but the a minus z, which is the number of say uh, your neutrons, that are going to remain the same. Now, radioactivity. This is a very crucial concept of this whole chapter, which states that Henry Becquerel actually discovered the phenomena of radioactivity in the year 1896. What he did was that he wrapped some, that what to say, uh, black paper, which is the very much radioactive in nature, in a dark room in near to a photographic plate. Okay. In the morning when he saw that how is it possible that these are that photographic plate is affected. Obviously, something struck in his mind. He did some research work. Ultimately, he found that these are the results of radiation. He named it becquerel rays. That is the concept. So, three types of emissions are there: alpha emission, beta emission, and gamma emission. Three types of emissions you need to remember. Now, the substances which disintegrate or decay by these spontaneous emissions are called radioactive substances. Anything, even me myself, if I am simply spontaneously emitting, my soul is emitting out of my body, releasing heavy amount of energy, that would be a form of radiation. Bad joke. This concept is very important. It states that radioactivity is a nuclear phenomenon. Any physical change, which is change in the pressure or in the change of temperature or in the change of chemical change, anything, it doesn't mind with the radioactivity. Radioactivity is something which is minded by the nucleus change, because nucleus is the thing which is involved in this phenomena. This clearly states that the phenomena is due to the orbital, due to the nucleons, and not by the property of the electrons. Next definition, you study this properly. Now comes the concept of radioactivity as emissions. Now, in 1903, while this man Rutherford, he was, doing experiments on radioactive substances, he found that on subjecting the radiations on the magnetic field, if we see, which is in perpendicular to the path of the uh, we see one thing, which is the left ones, they are basically the alpha rays, the right ones are the beta rays, and the ones which pass through the center, they are the uh, gamma rays. So beta rays, the deflect the most, the alpha rays deflect the less than that, and the beta rays don't reflect to any direction. Similarly, if we put the electric plates on either of the sides, we see that alpha rays, since they are uh, positively charged, they are more bent towards the negatively charged cathode, and the electric field, which is gamma rays, they are not actually charged, they are uncharged, unionized particles. So that is why they practically go straight without any further deflection or anything. Now, properties of alpha, beta, gamma, these you need to study by your own. I would recommend all of you to go that in depth, but side by side, you need to also keep in mind this thing that alpha, beta, and gamma radiation. This table on page 290, that is very important. Study well for your exams. Okay, now comes the primary point of this topic discussion which is going on, which is changes within the nucleus in an alpha, beta, gamma. Now see, in alpha emissions, what happens is there, An unstable nucleus contains practically more of say neutrons, as I said, more than that of protons. So practically what happens is that there is an alpha decay. In this, the you know both the it is the decay for two protons and two neutrons that are bound together. So ultimately the mass number is going to be 4 of that of alpha particle, and the atomic number is 2. So that is going to come. So A minus 4 and Z minus 2. See the decay formula. X, which is Az, gives me Y, which is A minus 4, Z minus 2, and helium. I had to tell you one thing, that is, in case of alpha decay, its mass is symbolizes the doubly ionized helium particle. An example is given to you. Uranium 238 splits to thorium 234 and a alpha particle. Second comes is that beta emission. Because of beta emission, what happens? In the nucleus, we have one neutron particle which transmits into the proton particle, as well as the uh, emission of one of the electron, which is in the form of beta particle. This is the beta particle, or you say beta emission. Thus, in case of beta emission, number of nucleons that remains the same. This. Remember, I told you isobars. This is an example of isobar. See, here it is given that one neutron changes to one proton and one electron, as well as an anti-neutrino, to conserve the mass. Mass conservation is very necessary in this case. Okay, so see the equation, which is P of Az gives me Q of A Z plus 1. As I said, neutron turns into a proton. So if it is turning into a proton, ultimately the atomic number is gonna add plus 1. And then our one more beta particle. Next is gamma emission. In many of the changes, it is found that by gamma emission, see, through both alpha and beta emissions, if there is that, I told you, the unstable radioactive element, if it does not get stable, it once again undergoes a gamma emission, which is to make it stable. This is we know that gamma is an electromagnetic wave, so it practically does not have any charge. It's just to bring the heavy nucleus into a ground state. Just wait a second. Yeah, so over here, in case of gamma emission, excited nucleus comes to a ground state. In a single radioactive decay, alpha and beta particles never emit simultaneously. Okay, so there will be either an alpha or an emission, or a beta emission accompanied by a gamma emission. Next, you study this chart and this uses of radioactivity, which is radioisotopes, which is Z, which is less greater than 82 in case of that, and uses such as cobalt 60, which is used in treating the cancer treatment. Another one is carbon, which is carbon 14. Then we have potassium. All these in medical uses, as I told you. Then Our scientific use is that in alpha particle emitted from radioisotopes, we use projectiles as over here. The industrial use, the radioisotopes such as uranium 235, it is used as a fuel for nuclear reactants. Okay, and ionizing effect of radiations is very much certain in the usefulness. Okay, now these things you have to just understand. Page number 230, 293, and the safety precautions is very much, you know, use lead tongs, wear lead aprons, use thick concrete walls for the radioactive station in all of that. Okay. Finally comes the concept of background radiation. Background radiations are nothing but these are the radiations which are exposed, and they are more active radioactive substances that are naturally present in the human body and as well as in the nature. You can see potassium 40 and carbon 14, and you see radium, they are already present in our body externally. If we speak natural, it is cosmic rays are there, radon 222. It is not possible for us to stop this anymore. We can't even stop the uh, UV rays because they're making the loopholes in the uh, coating of the earth. Okay, so that is the thing. We end up with this chapter. So over in this chapter, study these equations very nicely. This is the ending. Okay, as per your request, I taught you this chapter. So you all wanted to see my haircut, right? Wait, it's too much light. It's let's see. Wait a second. Wait a second. Wait a can see me, right? So that is the shape which I had brought it. So is it fine? Huh? During this exam season, I thought of bringing a new sort of fresh outlook. So I thought of bringing this. So how is it, Rovam? Yes, okay. So thank you for watching this stream. I appreciate all of you for the efforts, and all of you those who are watching this stream as in the form of a replay. Thank you to all for staying until this ending. You all have managed yourselves until the end. Thank you for watching. So with this is Nizam signing off for the session. Thank you for watching. Peace. Take care. Goodbye.